All right, so I know your notes look a little bit different this time, but we're going to do them this way. I did them on my iPad. So, write down everything that we're doing. We're moving into solutions to two variable equations, which starts our graphing unit. So, we're kind of switching gears a little bit. Graphing is really important. With linear equations, which is what we're going to focus on for a long time, you're just drawing a line. It's really 2 points and a line, and then some very specific information that we know about that line. So, when you have two variable equations, now you're talking about functions that might have a y and an x, not just an x anymore like we've been doing. So you can see that information in different ways. You might see it in a table like this, where you might have different values, and they're usually an input. We usually call it x, and then your output, which we usually call y. But I want you to think about what you're putting into the machine and what you're getting out of the machine. It's an easier way to think of it. Okay? So let's say you work at In-N-Out for $10 an hour. So if you work no hours, you get no money. You put in an hour of work, you get $10 out in your paycheck. You work 2 hours, you get $20 out. Work 3 hours, you get $30 out. Okay? You can also represent that as what we call ordered pairs, which is the same thing you've done as plotting points. So that will look like this, which we've done, right? You've still got an input and an output. For every hour you increase in work, you get $10 more in pay. And we can graph that. Okay? So let's go ahead and, if we were to do, let's say, we're not going to graph this one. Let's say you got paid $2 per hour per, I don't know, let's say per weed you pull. Okay, so this would be the number of weeds you pull. This would be the money that you make, right? So if I pull one weed, I'm going to make $2. If I don't pull any weeds, I make no money. If I pull 2 weeds, I get $4. 3 weeds, I get $6. 4 weeds, I get $8. 5, I get $10, right? And I can connect those dots, and now I've graphed that function. So now we're going to put that into more mathematic kind of words. And it says graph the function y equals 1/4 x with the domain 0, 4, 8, and 12. So the domain is all of your inputs. Okay? And those are always going to go along this horizontal axis right here. Okay? Typically, they're your x values. Okay? They're not always going to be x, but something that says what you're putting in the machine. Okay? So, for each of those, we can simply plug in each of those numbers, and we can sketch ourselves a quick little chart. Where are we going to do that? Let's do that over here. So, so all the things we're putting in the machine, y equals 1/4 x, we're going to put in 0, 4, 8, and 12. And those are going to be our inputs. And since I know I can represent them in a table or as coordinate points, I'm going to go ahead and do them as coordinate points. Okay? So I'm plugging each one of these values in for x right here. So I'm just multiplying. So for this output, I have 1/4 times 0, which is just 0. For this one, I have 1/4 times, my input this time is 4. And 1/4 of 4 is 1. Next one, I have 1/4, and my input this time is 8, which is 1 times 8 divided by 4, which gives me 2. And for this one, I have 1/4 times 12, which is 3. So and if we go back over here and let's graph that now. So we've got 0, 0. Make that even bigger so it's easier for you to see. So we had 0, 0 was a point. we had 4, 1. So over 4, up 1. And we had 8, 2, and 12, 3. So something I want you to kind of get used to looking at, because we're going to move into it kind of quick, is that for each, how far up and over you're going. And slope actually makes its own line, this little function. So I'm going up a certain amount and over a certain amount to get to the next point. So in this case, I'm moving up 1 and over 4. From this point to the next, I'm also moving up 1 over 4. And again, up 1 over 4. So how far you move up and over becomes your slope, or your rate, how much it's changing by. I'm going to call that rate of change. So in this case, it's moving up 1 and over 4. Okay? We'll come back to that. I just want you to kind of think about if that makes sense to you right there. Okay. The table below shows the average score M on the mathematics section of the Terra Nova for BRK. This is in a different country, but that's okay. From 2006 to 2011 as a function of time in years since 2006. Okay? So I want you to think about over here that we had a starting point, right? This was our beginning point. And if you want to think about it this way, oops, you want to think about the y-axis right here as kind of a starting line. Let's do this. Okay, that's your starting line. When you're graphing a line, you want to be able to start there if you can. That's where it begins. Okay, so, and then you're figuring out what you're counting. So this is based on the time. Based on the time, the score changes. So time is going to be on our horizontal axis, and we're going to call that T. And then the score is going to be on your vertical axis on this one, and they're calling that M. So you're kind of new to these, but they call these f of x functions, or in this case, they're going to be M of t. So it's the score M based on, that's an S, on time, which is t. Okay? We'll practice these a lot, so if this doesn't make sense right away, it's okay. And these are kind of odd amounts in this graph, so we're just going to kind of guesstimate. So let's make each of our vertical squares 1, 2, 3, 4, 5. That's going to be 0. We'll make those worth 1 each. And on the score side, we can make them whatever values we want. So since we need to go as high as 82, I'm just going to, let's see, 10, 20, 30, 40. I don't think we have enough for that. So we will just, every 2 we'll call 10. So every line would be worth 5. Okay. 60, 70. And we're just going to estimate. Okay, so 0, we're going to start off at about 60, 68. That's our beginning point right there because it starts right on this line. So 68 would be about there. Let me graph it in blue. Okay. After a year, it went up to about 73. Second year, it's about the same. Third year, it goes up just a little bit. Fourth year, it goes up a little bit more than that. And the fifth year, it's up at about 82. So this is not a perfectly straight line, but it's kind of got a line that we can kind of guide it by. Okay? Good. All right. All right. So now we're going to make a rule for each of these. Okay? So we have here our starting line, but we don't have a point on that line. So we're going to let that go for a minute. But we can see from each one of these dots how far we go up and over. Make that a little skinnier line. Okay? So if I was to make a triangle out of those, right? And we've got our line here. Okay. So all those triangles to me look like they have the same height and width, right? So from 1 to 3, it's increasing by 2. And then vertically, it's increasing by 1, from 1 to 2. Now if I look here from this dot right there to that one right there. So vertically, I'm going from 3 to 5, which also gives me, I'm going up 2, and then to get to that next point here, I'm moving over 1. And if I'm moving to the right, that's also positive. So that's my, how much it's changing, right? It's changing by positive 2 each time. Now what I have to figure out is where that beginning point would be. So if I know it's increasing as I go uphill, when you're looking at graphs, you're always looking left to right. Okay, then if I extended this line down, right, it should be down here somewhere, shouldn't it? So if I know that every time I increase, so let's write down the points that we have here. Let's see, we've got 1, 1. We have 2, 3. We have 3, 5. And we have 4, 7. We can stop there. Okay? And on each one of these, from 1 to 2, I'm increasing 1. From 2 to 3, I'm increasing 1. From 3 to 4, I'm increasing 1. And what's happening on the output side? Every time I increase by 1, my input, my output increases by 2. From 3 to 5, my increase is 2. And then from 5 to 7, it also increases by 2. So if now I need to figure out where that starting point was right there, I know that from 0 to 1 still increases by 1, and I know if I added something to 2, or sorry, added 2 to something and got 1, then I need to subtract it to get back to that. So 1 minus 2 would be negative 1. So that's my beginning point. And I want you to also recognize that every time you have a beginning point, the x value for that is 0. We haven't put anything into the machine yet. We've just started at 0. Okay? So beginning points always at where x equals 0. Okay? So in this case, we are beginning at, and I'm going to write it backwards just for a minute, negative 1, and then every time we change that x value, we're increasing by 2. Some of you are used to slope-intercept form that has this kind of switched around, but I want you to leave it like this for a minute because I think it might help. Okay? All right. So, number 1, this graph should actually be, let's fix this. Oops. This should actually be 3x plus 2. So change that in your notes to 3x plus 2. Okay? And I want you to think about what is the beginning value of that. So remember that beginning always is where 0 is the x value. So if I plug in a 0 for this, I have 3 times 0 plus 2. Well, anything times 0 is 0. So 2 is going to be my beginning point on the graph here. And remember, we're going to highlight that starting line, right? And our first point is going to be at 2. I'm going to go ahead and leave the big dots on it like that. Okay? Now, I'm going to plug in 1 and figure out what I get. So I get, when I plug in a 1 to the machine, I have 3 times 1 plus 2. 3 times 1 is 3 plus 2 is 5. Let's figure out another point while we're here. And 3, now I'm going to plug in 2 plus 2. So 3 times 2 is 6 plus 2 is 8. And look what's happening every time. So every time I increase by 1, on the input, I increase by 3 my output. Increase by 1, I go up another 3, because my rate of change on that is 3. So I go back over to my graph. Every time I move over 1, so over 1, I'm going up 1, 2, 3. Then I move over 1 and go up 1, 2, 3. So those 2 points would be at 1, 5, and 2, 8, which is exactly what we came up with mathematically over here. There's our points right there. Okay? And you can draw that line. Okay, let's write a rule for this function. Think about where it's starting, and we want to call that our initial value. It's a phrase I want you to kind of get used to. And all that is the starting point. Okay? So think about it again, and I'm actually, when we do this in class, I'm going to have you highlight the y-axis, the vertical axis, all the time. I'm going to start calling it the vertical axis all the time. And then that starting point in this case is right there. So that starting point in this instance is 2. Okay? Then the other thing I want you to think about is that line going uphill or downhill. And that line is definitely going uphill. Right? And you look at lines just like you do when you're reading. You read left to right. Right? So we're going to look at those lines left to right. And if I start here and end up over here, well, my line is going uphill as I look at it, or my output values are getting higher as I go. Okay? So now I just need to figure out how much they're increasing by. So here, if I move over 1, I'm going up by a half. Right? And then from this point here, I move over 1, but I'm only going up by a half. You can also look at it from large point to large point. Let's go from 2 way over here. Okay? It doesn't have to be points that are right next to each other. That rate doesn't change no matter where you're at on the line. So if I look at this triangle here, I'm going to say this is 1 point, that's 1 point. So I went all the way over here, all the way up. Well, in this case, horizontally, I went from 0 over to 4. So I went over 4, and then vertically, I went up 2. Whoops, 2. Okay? So every time I moved over 4, I went up 2. So for every 4 I had an input, I had 2 an output. And we're going to simplify that. So our function for that is y equals 2 plus 1/2 x. Okay? We're going to do lots of drawing today, so don't fret.